Hi, everybody. I am Troy Gilmore. I'm an associate professor in the School of Natural Resources and also Biological Systems Engineering at the University of Nebraska in Lincoln. And I'm excited to share with you about some software that we're developing. It has a lot of uses for scientific purposes, and I'll do a little whirlwind tour of that. But I think there's a lot of spin-off and thought going into it in terms of making it available for educational purposes, and maybe you can imagine that as we go through this overview. First of all, a lot of times I get the question of what is grime? That was made up in a lab at North Carolina State University during my undergrad research. If anyone knows transport beyond, spent a lot of Saturday mornings in the lab when I was an undergrad, and this is the GageCam Remote Image Manager Educational. We actually started as GageCam Remote Image Manager, so it was grim at first. We added the educational and got grime, and then most recently we brought in students who know something about machine learning and AI, and we tacked on artificial intelligence. But this has always been open source, commercial friendly, Apache 2.0, for those familiar with licensing. It's a Windows application that you can install. It was publicly released for the first time this week. And we're also deploying it on something called Open On Demand, which at UNL, that would be on Holland Computing Center. So you have an app basically with serious computational power behind it, and also at Northern Arizona University, where they have the entire phenocam archives for those familiar with that. The kind of background on this, and you've already heard about Platte Basin time lapse, and I'll refer to them several times. They're a big inspiration in this. I kind of dropped the project. I did publish it after my undergrad, but my PhD advisor was like, "You're going to work on groundwater heat treating and nitrate and not do this other stuff on the side." It was great advice at the time. But nonetheless, as you heard, Platte Basin time lapse has 70+ cameras instrumented across taking hourly imagery, daytime imagery across the whole Platte Basin. Those images are 10 megabytes a piece. You can imagine that stacks up really quickly to these large data sets. We were also, my undergrad project is more represented on the left here. Here we were putting this really specific target in the screen. And then that made it so we could use software to very quickly identify, for example, those bow ties. We know where they are in the real world, and then we could calculate water level. So on that left side is an image that takes a bunch of field work to set up, but then the processing of that image is actually really easy if you have the software to just click a few buttons. However, the reality is a lot more of the imagery that's out there that's time-lapse imagery. There's a lot of more people putting trail cams, game cams out, along with other networks that I'll mention. A lot of the imagery looks more like the stuff in the upper right, where you have no points of reference. You have, this is a wetland inundation study in south central Nebraska. You just have a sky and kind of some water and grass in the foreground. So those images are much, much more difficult to process and extract information out of. So that's kind of the why is that we're building this software, is to make working with this type of imagery much, much easier. There's a ton of information in those images. We'll talk about that. And there are also, as Heather mentioned, a proliferation of imagery. So USGS has a whole network of cameras. There are about 800, 900 cameras. It increases every time I look at it. There are maybe 13 or 15 of those in the Platte Basin, along with those Platte Basin at other locations. Then you also have the Phenocam network, which has about 900 cameras across the world, but especially in North America. A lot of those are looking at vegetation. But tons and tons of imagery out there, and we feel like we're just scratching the surface. And with the kind of students, even with engineering students, environmental science students who come in and don't have a ton of coding or computer science background, just diving in and trying to use images like this is a really, really difficult task for them. And so we're just trying to make that streamlined and much easier. So picture here of a bunch of team members, really great people here. I'm not going to name them all just for time purposes. And the bottom left is, or bottom center, I should say, is John Stranzel, who is really the lead developer of grime AI. On the far right over there is Ken Chapman. He came to UNL late in his career, as you can see there, and did his PhD with me. He was the one that wrote the water level software back when I was an undergrad. So it was a pretty cool experience. A lot of people were asking me what my degree was and stuff at this graduation when I was standing next to Kim. This whole list also lists a bunch of those people, but what I want to highlight are the different colors on the backgrounds and disciplines for people that are involved in this project. This is part of the exciting part of this, is that we have communication majors, biology, engineering, computer science, natural resources, and a whole mix of people all working and testing the software, using it, and so on. And the way that we're thinking about this, you already heard about data science and the data science process, is we really just, we're using the cell phone as the paradigm, right? Like a few clicks, taps, whatever, and then something happens on your phone. That's what we're trying to do, is just really streamline processes so a lot of different people with a lot of different backgrounds can use this kind of imagery for a lot of different reasons. So here's our data science workflow, starting with acquisition of data, cleaning, exploration, and then getting into modeling and maybe deploying models. The other thing that we're thinking a lot about is, unfortunately, underneath, partly covered, but the idea is we want a lot of off-ramps here for people. So maybe you get to, in a class project, you get to a data exploration part where you're visualizing things with imagery. Maybe that's all the farther you need to go, and it can still be a really effective product. And then you can peel off basically of a bunch of these different steps. We're really, a lot of that work is inspired by the things that Flat-Based and Time-Lapse is doing, and using imagery so effectively and creating narratives and storytelling around them. So we want to keep that in mind for users as well. So this is just an example right off the bat, trying to connect a little bit with the topic of education here. What you're seeing here in the imagery in the lower left is a site at the Kearney Outdoor Learning Area, which is a wetland that's adjacent to Kearney High School. We've had a camera out there for several years now, working with Mary Harner, who you heard about with Heather's talk. In the lower left is our image based water level measurement. You see an image for that. This is running on a server now. So we get every 15 minutes, we go grab an image from USGS website, and then we process it and show that water level on that image. On the right-hand side is kind of a built off of that inspiration of Flat-Based and Time-Lapse kind of composite slice image, where they're showing things happening over time by cutting out a bit of an image and showing it repeatedly. So at the top, you see a week's worth of water level data from a sensor on the site. And at the bottom, you can see noon at midnight images showing a week's worth also of imagery slices there. So you can see the water level kind of bouncing around there. That's also being processed automatically on the server as well. So just an idea, so we're building this in part to share with the high school. We also have water quality out here that we haven't integrated yet. But so this be something that the high school teachers can start to use. It's a little bit of a virtual lab, along with maybe occasional visits to this active site. But moving back to kind of starting at the beginning of this data science process, and I'll try to zoom through that maybe a little bit with the available time, and talk about the features of the Grime AI software itself. So I mentioned PhenoCam having hundreds of, I mentioned USGS having hundreds, maybe 800-900 cameras out there. If you install Grime AI and you open it up, this is a very similar, you'll see something very similar to this when you first open it. And basically on the left, you have the list of 800 or 900 sites. If you click on a site, you'll see the most recent image, so you get a sense of what's going on out there. And then you get a bunch of metadata there as well. A lot of these cameras are located at stream gauges. So if you select one of these and you go and download the imagery, you'll also we just go ahead and grab each page and discharge for you as well. Just put that all into one file. PhenoCam imagery is on the left. I mentioned they also have maybe 800 or 900 cameras. There's a small subset of those cameras, maybe dozens, maybe I think it's around 32, 36 of those cameras that are also co-located with lots and lots of instrumentation at these National Ecological Observatory Network, NEON. sites. And so what you get there, if you click on a site that has a camera, it shows you the latest image, and then it lists all of the data products that are available for that site. So you can select the imagery, you can select a bunch of other potentially sensor data, grab sample information as well. And then you can come over to the download page and you can choose the date range. You can also choose time of day. We wanted that so you could just download maybe noon imagery for a few years before you make the commitment of downloading tens of thousands of images. So we can do that download, and then you just have that on your local machine. Once it's on your local machine, it's just like the same kind of case where if you have your own trail cam imagery on your machine. From here on out, it could be your own imagery, it could be this publicly available imagery, but you're working now on your own hard drive. And our next step then is to clean the data. One way that we can do that, we wanted to do this in a systematic way. So you get imagery sometimes that's fogged over lenses, too light, too dark. You can imagine all the things going on. So this is a way to look at how blurry the image is and how bright it is, basically. You can set thresholds. And part of the idea is from a scientific standpoint, like being able to say, I set these thresholds and ran this algorithm and it cleaned the data set is kind of a nice thing to be able to put in your paper or report. And this is just an example of, for example, dark images being pulled out of a data set. We always keep all the data, we just put it into another folder. You can go inspect that folder and see what's been moved. So once you have your clean data set, now we can go to data exploration. Hopefully you're seeing not only the scientific side of this, but also maybe imagining students being able to do this in class. We're gonna have a workshop in March of next year and hopefully gonna trial that as well. But to explore data, this is another example of that composite slice image functionality. Here we're looking at a pond in Lincoln, Nebraska, where they have some floating treatment wetlands. They're interested in water quality. If you look on the far right side of the image and you look at that red vertical line, I basically used Grime AI. I selected that little thin sliver of an image on the far right side, and then I clicked generate composite slice, and it produced that image that's on the lower right side. And you can see the vegetation along this pond there that is green and brown and then green and brown and green. So you're seeing something seasonal happening here, right, with the vegetation. That kind of fits the phenocam, what they like to look at a lot. But then when you slice down the middle of the image, you take a little slice and you look at it, if you look down at the center image there, composite image, you start to see some other interesting things maybe. So for one thing, if you look down where the water would be, you can see those white kind of bands here. So here you have a frozen pond, basically, and you see whether there's snow. Sometimes you see snow on the bank, but not on the pond. So, but then right as you go through time from left to right, you can see that period where at least in that middle of the image, we had a bunch of algae there, right? So this is a way that people can very quickly generate this kind of compressed time and start to make observations about the imagery. And I think for class projects and things, this in itself could be really valuable for looking at imagery and thinking about what's happening over time. Digging into that a little bit more, we can also go on there and draw like these rectangles that you see on the left. So this is an image of Pecos River from USGS. So we can draw these rectangles, and for each of those rectangles, we can extract all kinds of information from that region of interest. So on the lower right, you see these different color swatches. So for example, we're extracting the dominant colors of the sky and the water and the vegetation. And then we can see that by clicking the build feature file. We can just click a button and it will create this huge spreadsheet that has all these colors and everything changing over time from this imagery. That can actually be used to model things. We have our demo project that we did and it's published. That was kind of a precursor to Grime AI. And in this case, we used plant-based and time-lapse imagery at the North Platte Weir on the western edge of the project. And what we did is we took imagery and actual stage and discharge data from a time period before and after, a few months of data. And then we artificially removed a year's worth of the hydrograph to see whether we could recreate that height graph based just on images between them. So for just some machine learning based on scalar image features. These are examples of things we were extracting. You can see that we were doing specific things like how much white water turbulent area downstream of the weir. That could be an indicator of flow. These are the kind of results we get in this study. The orange line is our model that is actually reconstructing, at least for 2 to 3 years, actually a decent reconstruction of the height graph or the discharge for this site. In the middle one, any modelers probably can guess what's going on here. We didn't have images with that kind of flow. Model blew up for that middle part there. So our next step, I just have a couple minutes. Our next step is to kind of move beyond drawing those rectangles and extracting that information. We've shown it can be valuable and we can do modeling from that. But our next step is to do things where we're automating it further. So we had a project with USGS where we worked with them to develop segmentation models that will physically look at this image, and as illustrated, I've just applied that red area myself. But the idea is it would be able to capture the portion of the image where water exists. So this is instant segmentation is what we're doing. And these are the 11 sites that we worked at with USGS, kind of a variety of sites. Flat River, Grand Island on the left, for example. And so we were using a SAM2 model, which is the Facebook basically model that already exists, but then we had students go in and draw polygons around lots and lots of images of drawing polygons around where the water was for our test and train data. And this that part takes a lot of time. That's just part of AI, ML type work that you have to annotate things in the real world. But setting up that model, or setting up the model so it could be trained, took 2 computer science master students working together about a whole semester to get that really set up in a robust way. It's a pretty time consuming, especially given their backgrounds. However, once we got that integrated into Grime AI and have this nice interface where you can just point at a folder of images and training data and stuff, I basically went back and retrained all those models in under a week myself. So it's just trying to illustrate that streamlined part. And then this is what it looks like when we run our model on these types of images. There's definitely images where it just kind of blows up and doesn't work this well, but for the vast majority of these images, we can extract out where that water is. Our next step is working with PhenoCam to next vegetation. We can do sky. We've labeled skies. We can do that as well. So you can start to look at a lot of other factors in images. But this is a pretty neat experience for a student to be able to train their own model and then boom, be able to see these overlays where it's actually technical. So maybe I'll just stop there with hammered away at the idea that we can do modeling on this. But we really are trying to make it very streamlined and usable in a lot of different settings, including the classroom. I do send out every 4 to 6 weeks updates on Grime AI features. I'll follow that QR. Any questions?
Have some of your students been able to start using the data in their research work yet, or is it still in process?
That's a little bit in process, but I'm on committees and we have students at other universities actually using it at this point. We've been so focused on the software development, it's hard to do the science part too, but there's some interesting projects that people are starting to apply it to, yeah.
So is this primarily for like undergraduate students, or is this for high school students, or is it a mix of both?
I think it can kind of work across that whole spectrum, yeah.
And then do you see this as like a, do you see this as like a drop-in supplement to a curriculum or like a specific class or set of classes, or is it its own set of curriculum? Like, how are you thinking about that in terms of how an educator might use this?
Yeah, I haven't really developed that in terms of like a formal, classroom setting.
Yep.
I can say for like the workshop we're kind of planning out in the spring, we want to really, one of the things that we're trying to do there is really bring in, for example, bring in PBT staff as instructors, right? They're conservation storyteller and professional photographers.
Yeah.
But bring them in the same room as some of the uh, people who are super focused on artificial intelligence, right? And get them talking across and seeing how you can bring out more science communication out of that, so on. So I've kind of trailed off of your original question. But we genuinely do have, I think there are portions of this software that are dead simple to use, like the composite slice stuff is just super simple. And if you do that, you can start talking about pattern change over time.
Okay, got it. And then maybe building off that, just one last question. So this is specifically focused in Nebraska. So if we want to use this in a different state, like how much of this could I just pull into like South Dakota, for example?
You can, it's, not sure if that one, I think that's the link.
I did, okay, yeah.
Okay. That'll take you to a form to download, the program, so anybody can use it, it's totally free.
Yep.
And once you get it, you can download anything that's on those public websites. And then if you have your own, say, Mesonet.
Yeah,
imagery or
like our own
something,
imagery.
yeah, then you can, if you have that on a hard drive or have access to it, then you can just point to a folder or directory or whatever, you can use this.
Okay, thank you.
You mentioned using the imagery to look at water quality. So can you talk a little bit more about what that looks like?
Yeah. Couple places we've dabbled with that is you can think about turbidity being one thing. We also have in our sand hills in Nebraska, we have these meadows that are a ton of organic matter in them. Groundwater fed streams, and you'll see these tea colored flushes of water coming out. And we have imagery, for example, that pairs with, you'll see just as a proof of concept, you can kind of see those things spiking and you see the color of the water change. One of our collaborators is working in a very flashy urban environment where they also have clay soils in the area, so you'll see flushes of color changes in the water. That's at a rudimentary level. Those are some of the things I'm talking about.
To follow up on that, Troy, you talked about the image and seeing that color, the visible light spectrum. Is there any cameras you have out there, or any plans to deploy something that's in other spectra for water quality?
Yeah, we don't have that. I'm not aware of that with the other, like the public databases. It's certainly an interesting question though, because that's, with satellites and they have that type of information that makes it really powerful.
Sorry, one last question. I don't mean to hog the floor here. I was just looking at the website here. So it looks like you're primarily looking at surface water. Has there been any work done looking at tile drainage and being able to use image recognition for estimating tile drainage?
I haven't done that personally. Francois Brigand has worked on that some at North Carolina State, and if you go thumbing through USGS, there's a bunch of Discovery Farms stuff, I think, if you're familiar with that, on the USGS HIVIZ site. I'm pretty sure that's what those are, but some of those have those, what is that that vertical ag drains that for control drainage?
Control
I
drainage.
forget the name of it.
Yeah.
There's several cameras looking down in there. It's kind of hard to see what's going on, but I'm just saying, like, that would be a place to go look at it.
Yeah.
But yeah, Francois has looked more like at the end of a culvert and tried to look at some kind of equations.